Is our existence in this universe an isolated phenomenon? Or is space in fact teeming with life? For answers, scientists are placing great hopes on one of the moons of a planet far, far away. More than 1 billion kilometers from Earth lies the planet Saturn. Hidden amidst its rings is a moon with good prospects of harboring life. Here's a backlit view of Saturn. Beyond its familiar set of rings is an outer ring that is thinner and fainter. The E-ring, discovered in 1967. The bluish-white E-ring includes one extremely significant body circling Saturn. Enceladus, one of Saturn's many moons. Diameter 500 kilometers. Its bright white color comes from ice. Enceladus appears to be covered in it. This image of Enceladus was taken by the Voyager 2 spacecraft in the 1980s. Seeing it, many scientists were astonished. The moon's surface is remarkably smooth. The elimination of craters in some areas suggests massively transformative tectonic events. Could it be that whatever is happening on Enceladus has something to do with the E-ring? As we shall see, the very human desire to solve this riddle leads us to place great hopes on the existence of extraterrestrial life.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
The Cassini Saturn probe left Earth in 1997. Its primary mission, to examine the relationship between Enceladus and the E-ring. Cassini's voyage to Saturn took 7 years. It reached the planet's vicinity in 2004. A quarter century after the Voyager mission, the mysteries of Enceladus are finally being addressed. In the western American state of Colorado is located the Cassini Imaging Laboratory. Here is where the imaging data collected by the Cassini probe are analyzed. The leader of the imaging team is Carolyn Porco. She says that starting with Cassini's very first image as it approached Enceladus, she was filled with astonishment. This was it. Enceladus appears darkly in this backlit image. Some might think the image anticlimactic, but Porco deliberately chose this backlit mode.
Some suggestions were that there might actually be geysers. There might be little volcanic kind of geysers coming off the surface of Enceladus, spewing tiny ice particles into orbit around Saturn and forming the E-ring. We, in fact, had planned our sequences of images to include observations where we're looking in the direction of the sun, so that if there was a plume of very tiny particles, we would be able to see it.
Here's an example of backlighting using a humidifier. We create a fine mist, normally invisible. But if we then shine a light on it from behind, the mist becomes clearly visible. This backlit effect was precisely what Porco had intended. Let's return to that first Cassini image. If we look closely at the south pole of Enceladus, we see what Porco had been hoping to see: a conspicuously bright portion. A month later, a backlit Enceladus was photographed once again. In the same location, one could clearly make out filaments of light, a plume being sent from Enceladus into space. Analysis of the images revealed that this plume extended more than 100 kilometers.
We had thought that we could find geysers on Enceladus, but what really, I think, made everybody just stand back in awe was the magnitude of this phenomenon.
July 14th, Cassini began a major phase of research. Reducing altitude to 168 kilometers, it made detailed observations of the terrain near the south pole of Enceladus. The mysterious moon then displayed features that even Porco had not anticipated. A number of vertical blue streaks. No craters at all. Just this series of parallel fractures stretching for 130 kilometers. The anticipated volcanic topography was not present, but it was equally clear that the area had seen robust geological change.
It looks totally different, unique. Not only did the imaging team get this incredible look at this region that no one had ever really seen before, which is the south pole of Enceladus, and not only did we find that it was geologically unique, it was characterized by this set of fractures and was crater-free, very bright.
The team called the blue streaks tiger stripes. The tectonic activity across this area was indicated also by the surface temperatures. The average on Enceladus is minus 200 degrees Celsius. But the tiger stripe showed a dramatic increase to minus 80 degrees Celsius. Some researchers estimate that the highest portions of that area rise to minus 20 degrees. Furthermore, the nature of the plume was revealed. Analysis of the data showed it to be comprised mainly of ice and water vapor. Conclusive images were also recorded. Clearly, what had looked like perhaps a single flare actually incorporated more than a dozen individual jets or geysers. Moreover, the jets were issuing along the tiger stripe fractures. And the material they released into space has been forming one of Saturn's rings. The bluish-white E-ring is thus a band of ice chunks formed by high-volume eruptions of ice from Enceladus.
I keep calling it the Enceladus Interplanetary Geyser Park. You know, that would be a great place. That would be one of the sightseeing, you know, the top 10 sightseeing locales in the solar system.
If we could actually land on the tiger stripes, we would be able to see their jets ejecting ice and vapor from the ice fissures at fearsome speed, some 100 meters per second. Rising as high as 100 kilometers, they would present a thrilling spectacle. And many scientists have begun to believe that Enceladus must harbor life. Why do they think so? It has been confirmed that there are certain forms of life capable of existing in a minus 40 degrees Celsius environment.
I believe it is very possible that there could be life in the tiger stripes of Enceladus. They're much hotter than what anyone believed possible, and we now know that microorganisms live in glacial ice all over the planet Earth. Therefore, there could be microorganisms alive and thriving in the tiger stripes of Enceladus.
Considering the sheer tenacity of life, it could well exist on Enceladus too. Of that, Hoover is convinced. Carolyn Porco, leader of the Cassini Imaging Central Laboratory. Porco believes that truly potent conditions for life are present under the ice of the tiger stripes. She thinks there's a large body of water there, in its liquid state. Water. It's the reason there's life on Earth. Across our globe, all sorts of life forms use water in all sorts of ways. Porco is convinced a huge amount of water lies under the tiger stripes.
This was about 153. So
her conviction originated during analysis of the Cassini images, when she noticed something distinctive about the jets.
And that's why it's clear. It's clear here. You could see the extent of it, how big it is. What we're seeing in these images of the jets, those are tiny ice particles, and we see so much of the solids compared to the vapor that is detected by the other instruments that the most plausible way to get that is from saying that the material starts out as a liquid and the liquid droplets eventually freeze and become the particles that we see.
Measurements show the diameter of the particles to be less than 1/100th of a millimeter. If these geysers were shooting out only broken up bits of surface ice, it is difficult to explain how so many particles could become so small. But if it was water that was gushing up, freezing after the spray had become droplets, then that would explain the large quantity of ice particles. But Saturn, around which Enceladus revolves, is 1.4 billion kilometers from the Sun. That's 10 times farther away than Earth. That's why the surface temperature of Enceladus averages minus 200 degrees Celsius. Any water on it would freeze, becoming ice. On this moon of ice, how could a large body of water exist in a liquid state? NASA's Jet Propulsion Laboratory, JPL, is located in the suburbs of Los Angeles. Inside is the control room for the Cassini space probe. Today they are again instructing the probe, 1 billion kilometers away near Saturn. Recently, Cassini has uncovered facts supporting the theory that liquid water is present on Enceladus. In October of 2008, Cassini drew very close to Enceladus on a low-altitude flyby. It was able to pass through the jets and to analyze their constituent matter minutely. One thing detected in the jets was ammonia. If ammonia is dissolved in water, it permits the water to maintain its liquid state even in temperatures as low as minus 97 degrees Celsius. In other words, it functions like antifreeze. But there is another factor melting the ice on this frigid moon. The movement of another of Saturn's moons, Dione. Enceladus revolves around Saturn on an orbit in between Saturn and Dione. Enceladus completes one orbit every 33 hours. It takes Dione exactly twice as long, 66 hours, to complete its own circuit. As a result, once every 66 hours, Saturn, Enceladus, and Dione are all lined up. Subjected to the gravitational pulls of both these bodies, the spherical shape of Enceladus is distorted into an ellipsoid. Then, as the alignment breaks up, Enceladus reverts to a sphere. When this happens enough times, the interior of Enceladus experiences a buildup of frictional heat. That melts some of the ice in the crust. It turns into liquid water. The hypothesis is that then, as the surrounding ice fractures, the water gushes out in jets.
Maybe a body of liquid under the surface of Enceladus. So the jets are an indication to us, actually, that we have on Enceladus a place where life might have gotten started.
An ocean under the ice of Enceladus, nurturing diverse forms of life.